Hallo, it's Dumplet here. Here's an item on number theory. Find the four smallest four-digit numbers such that by dividing by 2, 3, 4, 5, or 6, the remainder is 1. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, any of these four-digit numbers, when divided by 2, 3, 4, 5, or 6, the remainder is 1. So I can write it something like this. So let's just say the number is x, and it's 1 modulo 2. So, because it leaves a remainder of 1 when divided by 2. Now, obviously, I can replace this 2 over here with 3, with 4, with 5, and 6. Now, it's kind of difficult to work with something with a remainder. So let's try to deal with the following. So x leaves a remainder of 1 when divided by 2, 3, 4, 5, or 6. So let's try to focus on x minus 1. Now, x minus 1 is actually nice because x minus 1, well, if you guys know modulo, we can just subtract 1 on both sides. So like x minus 1, well, since x leaves a remainder of 1 when divided by 2, 3, 4, 5, or 6, then subtracting 1 from x, it's going to give you 0 mod all of these. So it's 0 mod 2, 0 mod 3, mod 4, mod 4, mod 5, and mod 6. So having this property is nice because, well, a remainder of 0 means x minus 1 is simply a multiple of 2, 3, 4, 5, and 6. So, well, since we're talking about being a multiple of a lot of the numbers, then let's just try to take the LCM. So we can say that x minus 1 is a multiple of a certain number. So all you have to do is just take the LCM of 2, 3, 4, 5, and 6. So here we have the prime factorizations of all these 5 numbers over here. So by elementary techniques, the LCM would be 2 squared times 3 times 5. So we just take the largest prime power, which is in this case like the 2 squared is the largest, the 3 is the largest prime power of 3, and then the 5 over here. So the LCM would be 2 squared times 3 times 5, and this equals 60. So we can say that x minus 1 is a multiple of 60. Now, since we're finding for the 4 smallest 4-digit numbers, so let's try to just analyze the number 1000. So the 1000, if you manually divide it by 60, you're going to get that it's 40 modulo 60. So what does this tell us? So 1000 leaves a remainder of 40 when divided by 60. So from this, we can get that if I add 20 to both sides. So since having a remainder of 40, meaning you're 20 less than the next multiple of 60, right? So if you have a remainder of 40, you're missing 20 until the next multiple of 60. So 1020, it's going to be the smallest 4-digit number that is a multiple of 60. So we can assign x minus 1 the values 1020. Now obviously I can keep going up. So 1020, 1080, 1140, and lastly 1200. So I can continue this thought, but we're just asked for like the 4 smallest 4-digit numbers, so I'll stop right there. Now, since x minus 1, the 4 smallest possible values of x minus 1 are these 4 values, simply add 1 to all of these. So adding 1 to all of these terms, we're going to get that the 4 smallest possible values, the 4 smallest possible 4-digit values of x is 1021, 1081, 1141, and 1201. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.